Before we start this problem, let's review what it means to be a critical number of the function g. To be a critical number, you are x equals c that fits one of these two conditions. Either f prime of c is equal to 0 or f prime of c is equal to does not exist. I mean g prime, not f, because this function is g. Okay, keep that in mind. Let's do this problem. We're given g of x equals x plus 2 times sine of x. We've restricted our domain from 0 to 2 pi, which makes it much easier. And we're asked to find the local min, local max. So step one, we're just going to figure out what the derivative of g is, g prime of x. Just look at the original function g of x. The derivative is 1 plus 2 times cosine x. Step two, we're going to partition or divvy up the number line, and we'll do it using the critical numbers of the function g. Now remember those two conditions that can exist to have a critical number. I want to exclude one of those conditions now in this next explanation. For this particular function, we have it defined on all real numbers. I'm talking about the g prime function. It's defined on all real numbers. So there are no values for x for which g prime of x will not exist. It's defined on all values of x. That means we're not looking for those critical numbers. We're only looking for the critical numbers that are zeros of g. In other words, the values x equals c that make g prime of c equal to 0. Okay, let's search for those. And let's restrict our search for these x values on the interval from 0 to 2 pi. Now to figure this out, we have to solve one of those trigonometric equations. We'll have to use the all students take calculus to figure out positive or negativeness of the trig functions in each quadrant. Here's a 30, 60, 90 triangle. I'm going to jump ahead and tell you what I'm interested in. I'm interested in the reference angle, theta equals pi over 3, but I'm only interested for that in quadrants 2 and 3 because I'm going to need a negative answer for the cosine. Now why am I saying that? It's because if I take g prime and set it equal to 0, I get 1 plus 2 cosine x equals 0. Solve that for cosine x, I get a negative 1/2. So I'm looking for the value of x, the angle, the real number angle, that gives me a negative 1/2. I know that pi over 3 would give me a 1/2 in the first quadrant, but I want this to be negative, so it has to be the reference angle pi over 3 in quadrant 2 and quadrant 3. Let's draw those two guys. Here's the first and the second angle. This is a circular graph. It goes from 0, pi over 2, pi, 3 pi over 2 to 2 pi. Here's my first answer. It has reference angle equal to pi over 3. And our second one is in the third quadrant. It has reference angle pi over 3. Okay, how do you figure out what these angles are? Well, what I'm going to do is for the first one, I'm going to take pi and subtract pi over 3. And that means that my first 0 of g of prime of x between 0 and 2 pi is going to be 2 pi over 3. Then for the next one, I add pi over 3 to pi in the third quadrant, and I get 4 pi over 3. Okay, and now I'm just going to repeat what I said at the beginning of step 2. Since g is differentiable everywhere on all real numbers, I should say g prime is differentiable everywhere, not g. In other words, because x and cosine x are differentiable, there's not going to be any other critical numbers of g than these values, these zeros that we found. So we've found all of them. They are 2 pi over 3 and x equals 4 pi over 3. Those are the critical numbers of g. We'll use them to divide this number line. We're also going to make mention on this number line the endpoints in the restricted domain. So the first thing we'll do is we'll draw this number line and we'll mark x equals 0, then the first critical number 2 pi over 3, the next 4 pi over 3, and then the endpoint 2 pi. Now we're ready for step 3. In step 3, we're finding, solving g prime of x equals 1 plus 2 cosine x. We're going to try to find the sign, positive or negative, in each region. So let's first set g prime of x greater than 0 and solve for the solve this trigonometric inequality for x. It'll tell us which regions give us a positive derivative. And we'll do the same thing for a negative derivative in the next note.